Hey everybody, I'm Alex Stevens. I'm one of the evangelists here for Epic Games in Australia and New Zealand, and I'm here to show you that building tools in Unreal Engine is way easier than you think. So what we're going to cover is a brief introduction into building tools and Blueprint. So we're not going to touch a line of C++ at all. This is all going to be in the editor. So we're going to jump into construction scripts. So you've probably used these in the past. They're the ones that can fire off every single time you modify an actor in the level editor. And then we're going to jump into editor utility blueprints. These editor utility blueprints are, as they say, editor-only blueprints that can access editor-only functionality of the engine. So a lot of subsystems, like being able to do post-import scripts, even kicking off Python scripts and other things. But in today's talk, we're going to be going over actor and asset actions, which give you context menu options when you right-click on actors or assets, and then allow you to just fire off arbitrary blueprint functions. And then we're going to go over editor utility widgets. Editor utility widgets use Unreal Motion graphics under the hood to basically provide you a what you see is what you get UI editor. And then you can tie in, like your normal editor utility blueprints, any editor functionality, which is pretty cool. Now, in this project, we've got a mineshaft, but like any mineshaft, we need mine tracks, right, for it to count in. And usually what you'd be doing is you'd be dragging these static meshes and just connecting them one by one. But what if I told you there's a better way? Well, in the engine, we have this concept of actor construction scripts. And so what we're going to do is we're going to create ourselves a track actor. And in this construction script, we're just going to print a hello so that every single time we move or modify this actor, it will run that construction script. And so what we're going to do is we're going to add ourselves a spline. And this spline is going to drive some functionality to spawn a bunch of spline meshes. So what we're going to do is we're going to loop over the entire spline, and then we're going to add every single segment length a new spline mesh. Now, if you don't know what a spline mesh is, don't worry too much, because we're going to show it off very soon. So let's go and grab our mine track, and we'll assign it to the spline mesh component. And we're just going to create at least one component. So now you can see that the spline mesh is in here. And what we're going to do is we're just going to grab this spline, and we're going to push it down the track. Because what we're going to do is we're going to use the spline mesh components to then spawn along this track, and then warp along it. So now let's go back to our blueprint. And what we're going to do is we're going to grab the length of the spline, and then we're going to divide it up into a bunch of segments so that for each loop that we do, we add a new spline component. So we're going to create ourselves a segment length variable. We're going to call that segment length, and then we're going to just compile it. And what we need to do is we need to set the actual value of segment length. So let's hover over our static mesh. We can get the approximate size from here, and then we set the value to 250 because it's 250 units long. So now we are generating a mesh every single 250 units, but they're not conforming to the spline. So we need to set start and end tangents. So what we're going to do is we're going to get our spline, and every single segment that we want to add, we need to get a location, and we also need to get a tangent. And so we can set the start position and the start tangent at the current position along the spline, and then we can get the next position and tangent and set the end position and end tangents. However, we haven't specified the distance just yet. So because we've got this loop, we know we're up to, say, 5th segment. So let's get that 5 multiplied by the segment length, and that's going to be the distance along the spline. But that's going to be the end position. So what we're going to do is we're going to get the last position to be the start. And then what we need to do is we need to make sure to start from the first index, because we want to start first and read the last position in tangent. So now we can see that we've got a spline that's looking a bit odd, but we can fix that. So let's go ahead and we're just going to clamp those tangents to the length of the segment lengths. And so what this is going to do, it's going to make sure that that spline mesh doesn't overextend itself. That's why it's kind of turning in on itself. So we've compiled that. So let's take a look. Hey, this is looking very good. So as you can see, we can just drag in new tracks, and each of those segments will dynamically populate, add in. We can snap them to the ground using the N key, if you didn't know about that. And this is way easier than having to go through and actually like manually place these, or even pre-create these in Maya or 3ds Max, right? And you can actually bake these out as static meshes. So constructor scripts are great for individual actors, but what happens if you're wanting to do a function where you want to manipulate multiple actors at the same time? So this is where edit utility blueprints come in. So what we're going to do is going to create an edit utility blueprint. And don't be scared by this panel. There's a couple of classes in here, some of them notable, like the edit utility actor. But what we're going to create is an actor action utility. And this actor action utility, it's a special kind of blueprint that whenever you add a function to it, and say we want to just print a string, right? Whenever we select an actor, we've got the scripted actions menu. And when we click do something, it'll print or do whatever we tell it to. So now we are going to do something a little bit different. We're going to create a scatter function. So this scatter function, what we're going to do is we're going to use some edit utility functionality to get all of our currently selected level actors. We're going to iterate over each one of those actors. What we want to do is we want to kind of simulate a ballistics path. And you can do that by the predict projectile functionality in the engine. And so we're going to get our current actor's location. We need to specify a world context object, because this will show up now. And we need to set the trace channel to be visibility. And we'll also specify a launch velocity, and we'll just use a random unit vector and cone. So we're going to point that cone upwards. We could specify anything if we want to, but we're going to send it off in a random 30-degree direction. But at the moment, it's only going to be a unit vector, so the strength is 1. So what we need to do is we need to specify a min and max throw speed. And so this function is going to effectively toss our actor in a direction. But this projectile path might hit us. So we're just going to say, ignore all of the selected actors, and then we're going to draw a bit of debug lines, 5 seconds, so that we can see what it's going to do. So let's select them, and we'll scatter. And you can see that there's a bit of a projectile path generated. A nice little parabolic path. Cool. So we need to set our location of the actor. So we could just say, hey, set actor location, right? And then we'll just get the last trace destination, set that, and I'll just clean this up, because you gotta be neat in your blueprints, right? You don't want spaghetti. So let's test it out. So now you can see that it's penetrating in, but that's because the pivot point of each of these meshes is at the very bottom of the barrel. So what we need to do is we need to do something called a sweep. So we need to basically iterate through all of the path positions that were generated by our projectile path, and we need to move our actor along that projectile path. So we're going to do something similar to the construction script before. We're going to get the last position and the current position, and then we're going to get the delta between those two positions. So we're going to get, this is the last position. We're going to start at index 1, and we're going to get the difference between these two positions, and that's how far we're going to move it. So every single time we run this loop, it's going to move it just a little bit in a single direction. Just clean this up. And we'll tick off the sweep. And that sweep is basically going to make sure that anytime we move that actor, it's going to test for collisions. So when we scatter, you can see that it's laying flat on the ground. Cool. Now, what happens if we want to adjust this min and max throw speed? Well, what you can do is you can just drag these nodes in, add some parameters to your function. And what we'll do is we'll set the default values to our 300 and our 500 values before. And when we run this next, it will throw up a little panel to specify our min and max velocities. Sweet, so now you can see we've thrown one off to the side of the cliff. And that was super easy, right? Now, what about other types of actors? Because we probably don't want to throw the track, right? So inside our blueprint, what we can do is we can override the getSupported class. And we're just going to specify that we only want to apply this to static mesh actors. So we'll compile that. And when we right-click our track, it doesn't show up the context menu. However, for our barrels, it shows up the scatter. Sweet! So now you can direct tools for only particular actors. Now, what about assets? Well, you can create another editor utility blueprint and do the same functionality, but with an asset action utility. So let's create that blueprint. And it works exactly the same way as an actor action utility. So you open it up, you can create your function. So let's just do something to our asset. We'll iterate over selected assets. So we can access the content browser. And for each one of those assets, we're just going to print ourselves the name of the asset, just to show you that it can be done. Cool. We can hit compile. But we can also override the supported classes, like before. So let's go and test it out. So we'll select a couple of assets, we'll right-click. We can see that context menu action, and we've just printed off all of the asset names. Sweet. And we can do that for blueprints as well. So as you can see, action utilities are super useful for bulk changes. But what happens if you want to do something a little bit more complex, like a level editor tool? Well, you may want to do something like a tool where you snap stuff 45 degrees left and right. We could just use the transforms, but I want to make a tool to make it quick. So let's make an editor utility widget. Now, an editor utility widget is basically a UMG widget for the editor only, but we can show it as an editor tool. So if you haven't seen UMG, you can create a bunch of panels that contain stuff like buttons, and you could text. And then for the editor utility widget side of things, you can just right-click the widget and say run it. So now we've got a quick little button, but we can also dock this thing like any other window. So let's go ahead and we're going to start create a little tool to snap those actors left and right. So we'll make a negative button. I'm going to just put some padding on this button. And we're going to wrap it with a horizontal box because we're going to have two of these buttons next to each other, like to the left and right. So we can rename this. We'll call it our negative rotation. And then what we're going to do is we're going to duplicate it and make the positive rotation. So let's change the icon to be a positive. And we'll center this whole thing because everything's nice and centered, right? We'll add a bit of padding. And now we've got two buttons. Cool. So let's give this thing a little bit of functionality because it does nothing. So just like UMG, we can add our events for our pressed. So what we're going to do is we're going to go through and we're going to get our selected actors, just like before. We're going to iterate over them. What we're going to do is we're just going to add an actor local rotation. Then we're going to snap 45 degrees around the roll axis. So let's compile that, give it a quick test. And as you can see, we've got our snaps. Cool. Right, so what we're going to do is we're going to collapse this to a function because we're going to reuse it. And what we're going to do is we're going to call it do rotation. And we're going to create a rotator that's going to snap around our axes, but we're going to give it a direction. So we'll add in a new pin, call that direction. We'll give it a default value of 1 for positive rotation, and then we'll set the rotation to 45 degrees. We'll compile that. And then what we need to do is we need to add our extra press event for our positive rotation. So we'll set our negative rotation to negative, and our positive to being positive. And so now we've got our snaps left and right around the x-axis. But what about another axis? So let's go back into our blueprint and we'll add in a couple of extra widgets to be able to choose those axes. So let's add in an extra horizontal box. So we're going to lay these extra axes out from left to right. We'll add in a checkbox. We'll rename that checkbox checkbox X. And then what we're going to do is we're going to add some text to obviously show off that is the X checkbox. And we're going to wrap it with a horizontal box. Make sure that the checkbox is in next to it. Now let's rename that text to just be X. And what we're going to do is we're just going to make sure that horizontal box is centered. And our X value is a little bit too small. So let's make it smaller. And we're going to duplicate all of these widgets to make our Y and Z axes. So let's fill them in. We'll also rename the checkboxes. And we'll give a little bit of padding. Now we'll compile that. But I almost forgot, we can also set the default value of this checkbox. So let's just make sure that we're rotating around the x-axis. So we can see we can check and uncheck each individual checkbox. So when we do our rotation, we're going to want to check those checkboxes. So let's go ahead. We're going to make ourselves a make rotator node. And then from here, we can get the current check status of each checkbox. So we can get this checked. And then we can just drag that into the float, and that float will return 1 or 0, depending on if it's checked. So let's do that for each axis. But now we've lost the rotation amount. So let's drag out another float multiplier. We'll enter in our number of degrees, which is 45. Compile that. We'll give it a quick test. Cool. So we've got rotation around the x-axis. Sweet. Now let's do it just around the y. Cool, that's working. And as you can see, that's pretty easy to put together. We can apply rotations along multiple axes at the same time, and we can still reset. So super nice for your level designers. But now, what happens if we wanted to configure that rotation map? So let's create a property. We'll call it rotation amount, and we'll add it to the properties category. We're just going to type this in. You'll see why in a tick. Because what we're going to do is we're going to add in another widget, and this widget is a details view. And this details view is the same widget that's used for the details panel in Level Editor. However, you can see that it's just set as an undefined object. So what we need to do is we need to specify the object that it is going to show the details of. So let's go in, we'll grab our details view, and we'll call set object on. And this is going to sound weird, but we're going to set it to ourselves. Because what we want to do is we want to show the rotation amount that we just added in before. So we've compiled that, and now we can see all the properties of our widget. So we've got the rotation amount, which is cool. So we can put in a value of 1, we can tick it up and down, it'll increment 100 degrees at a time. But we've got a bunch of these other categories that shouldn't be there, right? So let's go back to the designer. And we're going to force the details view to only show the category of the rotation amount, and that was properties. So as you can see, our rotation amount is in properties category. And so we only show the properties category. So as you can see, details view is a nice and easy way to add configuration to your widget, and your developers are going to love you for the tools that you make for them. So what are some other ideas that you could do with edit utility widgets? Well, for example, I created this time of day system. So when I hit play, it'll automatically update the sun position and any other actors that implement this particular time of day interface. But the other cool thing is with editor utility blueprints, you can actually extend your toolbars and your tool menus. So for example, when I click this button, it opens up the time of day system. Under the hood, all it's doing is we're registering this blueprint as a startup object, and then we're adding our tool menu to the tool menu's subsystem. And then whenever that button is clicked, this one, we're going to just run a spawn tab, which will open that time of day editor utility widget. It's pretty cool. There's also other editor subsystems. So for example, the import subsystem, which will allow you to bind events to import. So for example, if you've got a pipeline where you import a static mesh and you want to change some properties on there, you can do that. And then you could even use set editor property to set the properties of C++ variables that aren't exposed to blueprints. And you can also do get editor property too. And these are two functions that are editor only. There's also a bunch of other functions, like if we go down to the editor scripting category, we've got a ton of other stuff. Like for example, being able to check out assets. There's a lot of level creation stuff, being able to destroy actors, and even start and end play. So being able to do simulated worlds programmatically, like spawn a bunch of actors, store them, and then save them in the editor afterwards, right? That's pretty cool. So as you can see, building tools in Blueprints is easier than ever. And if you spend a little bit of time developing tools now, you'll save a ton of time down the road. But there is definitely a lot more features in editor utilities that I haven't covered in this talk, so definitely explore around. And we have a ton of documentation online. There's even a couple of how-tos there, so check it out. So thanks for watching today. Hope that was super insightful and that it'll inspire you to try out editor utilities yourselves. And if you do have any questions about them, feel free to reach out to me on Twitter. My handle is MilkyEngineer, or over on my email at alex.stevens@epicgames.com. Thanks, folks.